So this is about CAMS 283. Some people call it the little brother of CAMS 282. So this is about regional model evaluation. We evaluate all regional models of CAMS and also the regional ensemble. And the old guys among you will remember that surface evaluation of regional models was part of the old CAMS 50 contract, while the above surface evaluation of regional models used to be CAMS 84 until last year, and that was combined into CAMS 283, which was signed this January. So it's quite new still. Why are we doing this? It's, of course, control and monitoring. I mean, all the modelers, I can assure you, are dedicated scientists. But anyway, it makes sense to, if somebody is watching, none of us wants to be worst in class, at least not for a longer period of time. So this just gives us another incentive to perform well. And while I don't think that users spend too much time on reading our reports, I'm sure that they appreciate that there are clear procedures of evaluation and quality control in place, and that they can look at our model performance if they want to. Another important aspect, in my opinion, as a modeler, is that we can detect any issues with the models fast. That's the point with near real-time evaluation. And that we can provide hints for further model development. And also monitor performance, model performance over time. This is to acknowledge all the partners. It's MET Norway, Météo France, INRIS, KNMI, CNRS, and FMI. I will acknowledge all of them when I show their main products. What we do is daily web graphics. That's the near real-time evaluation I just mentioned, of forecast and analysis from CAMS 240. And we do quarterly evaluation and quality control reports of the forecast and analysis. And we also issue annual reports of the interim and validated reanalysis, also from CAMS 240. And as many contracts nowadays have, we have a dedicated work package on user support and documentation. We will have a huge documentation document end of this month, and we collaborate with the CAMS knowledge base so that all our metrics are visible for users and also for providers. I've been in this modeling business for almost 3 decades, and it shows that what modelers write in their reports hasn't changed that much. But I can assure you, seriously, that the complexity of models has increased a lot. And you can learn more from models. They are more reliable in terms of forecasting. And also what we mean by reasonably well and satisfactory has changed over the years because the applications are so much more advanced nowadays than they used to be like 25 years ago. Anyway, we need to quantify what we mean by what is a good model, and we have those standard statistical parameters like root mean square error, fractional gross error, correlation, and so on. And we define targets for those, and we report on those targets if the models reach those targets or not. We also look at whether or not they are improving. They should ideally improving all the time, or at least not get worse. So this you will find in our reports. And also an important aspect is that the exceedances of air quality standards are well detected or predicted by the models. And we have this new thing, fair mode, new in terms of CAMS, which provides you in a way with a summary of the summary. I will show you a plot at the end of my talk, so that users can judge very quickly if a model is fit for purpose or not. This is a list of links. I don't have time to click through those, and I'm also not equipped to do so. But please feel free to click through the links. You will see a lot of nice plots that Météo France have done. They have many years of experience, so those plots are wonderful. They are now organized on the right menu of the regional Atmosphere Copernicus portal. As has been mentioned several times, Aroval, developed by MET Norway, is taking over that service. So this link resembles very much to the one Henk just showed you. Just replace 82 by 83, and you will see all the plots we provide for the regional model evaluation. If you're interested in reports, all the EQC reports back to the dawn of time are published now here on this page. So this is just a screenshot of this new Arroval page that is being developed. I will show a little bit more of that in a special session later this afternoon for CAMS 240 and CAMS 283. It's still a prototype, so I will include that in my plenary presentation next year when it's operational. But it's a large team at our institute that is behind this, and I'm grateful to all of them. This has been done by Metro France, so probably most of you have seen these types of plots. We have different statistical parameters as a function of season, several years back, so you can here monitor the change in performance for each model. This is the example for EMAP, but you can see these plots for all models in the reports. And then we have these special types of plots that show you statistical scores as a function of forecast hour. As you know, we issue 4 days forecasts, and you see here whether a model degrades, and if so, how much over the forecast time. This is another type of plot. I mentioned that exceedances are a very important output from a policy point of view, and this is done by Ineris. It's here the so-called mean performance diagram. On the vertical axis, you have probability of detection. That's the fraction of all correctly modeled exceedances among all observed exceedances. So the less missed alarms you have, the better you are, the higher up in this plot you are. And then the success ratio, that is the fraction of correctly modeled alarms among all modeled alarms. So the less false alarms you have, the more to the right you are here. Or put it simply, you want your model to be in the green spot. And you see not all the models are in the green spot, but this is a focus area nowadays. We are trying to improve this in our models. Another type of plot, many of you, they are not new, but they have been improved now during CAMS 283. This is evaluation against ozone zones. Our colleagues from KNMI have been doing this, and it's not that well visible on this screen, but the shaded area, maybe you can see it, shows you the envelope. It's the spread among all the regional models. And then you can see one model, in this case, it's the example of match, compared to observations in black, and we also include the ensemble and the CAMS global model. To the left, you have the forecast, and to the right, you can see how well the data simulation works. You see here is an overestimation, and that is removed effectively by the assimilation, but you also remove, you get an underestimation in upper levels. I will come back to that in the special session for modelers, because that's interesting for us. And the same type of plot is made by CNRS. This time it's not ozone zones, but it's aircraft measurements, and we have both ozone and CO in our reports. They are showing the same thing, but against aircraft emissions. Also really interesting to see performance in terms of CO. This is a new type of plot in the regional evaluation service. We use now Sentinel 5P data, TROP-OMI, NO2 columns to look at vertical total tropospheric columns of NO2. This is an example for the ensemble, the regional ensemble, for the winter season, last winter season. And it's the ensemble minus TROP-OMI. So everything which is red is an overestimation, and everything which is blue is an underestimation. So that has also got some attention, because it shows that when we include data simulation, the regions of overestimations increase, although surface performance improves. So sometimes we need to choose between improving the models at the surface or at upper levels. Ideally, we would like to improve them at both upper levels and the surface, but that is something we have to discuss, and it will be discussed this afternoon in a special session. And the last slide, this is fair mode, as I have mentioned in the beginning. Those are really busy plots, but the nice thing about them is that you only need to look at this number, MQI 90, it should be below 1, then your model is good. And you have to look at the color of these dots. If they're all are green, then your model is good. So I'm oversimplifying here, of course. If you are interested in the details, then you will find the details in our reports. But I really think seriously that it's a good thing about those plots that busy people can just get a first, they see the conclusion, the summary of the summary in the plots. And those who are interested in details can do that too. So finally, what is new in CAMS 283? Henk had about 10 slides about what is new in CAMS 283. I have only this one. We combined surface and above surface evaluation, and we added new species. I didn't mention that, but it's SO2 and CO, which is now new in the regional evaluation. We have new types of plots. I showed you a few examples, and some people have said there are too many plots now, but I have been unable to choose or to cut down on the number of plots because there are so many users, so many providers interested in different things. So I think we will keep those plots and rather make it easier to navigate. And the Arroval webpage is very nicely designed, so everybody interested can navigate relatively quickly to the types of plots or the species he or she is interested in. So visualization through Arroval, that's new, to be done during the next year. If I haven't mentioned Arroval yet, it's being operationalized, and it will be operational in 2023. The addition of pollen, I didn't speak about pollen at all, but I will do so in the afternoon sessions, so be prepared. This is something that has to be done this year as a first step, and then in a more advanced way next year. And then, yeah, documentation, I mentioned that, and continuation of service, that's a lot of work. The computers don't do everything by themselves. It's a lot of work to just continue the service. Okay, so now coffee break.
Yeah.
Thank you very much.
Thank you. Again, there's time for one burning question. Martin.
Yeah, thanks very much to both speakers, actually. And I have a question also concerning both of them, so Henk and Michael, which is the use of skill scores. So in the meteorological community, people are very much used to having a reference model as a base case, basically, to then evaluate how much you gain by actually having the complex model system run against that. And I have so far at least not seen that in the CAMS validation report. So I'm wondering if there's a plan to introduce something like that. Thanks.
Did you say persistence model?
For example, it can be persistence,
yeah,
can be
persistence model,
climatology or something else.
Yeah. That's included in a type of fair mode plots that we're going to implement. I think the fair mode representatives are here. There's one plot that shows comparisons to the persistence model, as far as I remember. But you are right, so far, at least in CAMS 283, it's not, we don't have a reference. We just use observations and the ensemble model to judge performance of individual models. Henk has probably more. He's looking for the microphone anyway.
Yeah, maybe I can add a little bit. So we also have something I didn't talk about, but we also have a separate activity to look at headline scores. So that's something that will come back, and we are currently defining how we set this study up. But we did that already in the past report, and for instance, Michael has come up with a nice score for Aeronet. And so really also a summary of the summary. So really starting from a reference, climatology, and then see how much you gain within the CAMS system.